Welcome back to Mograph Plus. It's Kamel Khazri here with you. In this section, we discussed lights and lighting in Arnold for Cinema 4D. In order to create a light, you can go to the C4D2A menu, Arnold Light, and here you have access to all the Arnold provided lights. As I have this menu duct here, I can simply go and click on any Arnold light here, select the light type, and add it to the scene. I think I have already mentioned it, but the C4D2A menu might be removed from the extensions menu and be added as an independent menu up here in the future release. As always, we are in the ACES workflow. Make sure to check out the introductory video I did on ACES in the introduction section of the course, or check out the in-depth one in the rendering section. Before going any further, let me quickly walk you through the scene. Just a simple wall, the floor, and a chair. We have also a glass and a chrome sphere that will be used as we progress through the lesson. When we try to create an Arnold light, there are different types of light that we can go for. You got cylinder light, disc light, distant, mesh, photometric, point, quad, sky dome light, spotlight, and light portal. Each type has its use and function, but they have lots of common attributes. The light type that you probably use more often is area light. We have 4 different area lights shape-wise: cylinder, disc, mesh, and quad light. Quad light is exactly the area light that we are familiar with in Cinema 4D, that rectangular light that emits light rays from every point on its surface. And this is the light type we use it all the time because it kind of resembles that smooth, soft lighting from softboxes in real world. So it's pleasing to the eyes. We start with that to see what a typical Arnold light has to offer. So let's add an Arnold quad light and run the IPR. One of the cool things you can do in the IPR is to define a camera to be used as the active camera. And this way, no matter the active view in the viewport, IPR will always use the camera that you have defined in the camera dropdown here. We have this camera in the scene that's called camera 01. So let's use this drop-down menu in the IPR and set it as active camera. It's hard to see what the light is doing because it's not as bright as it should be. So let's increase its exposure to around 4 to make it brighter. Now let's get out of the camera and start positioning the light. The light is so big and produces very diffuse shadows. So let's select the light and in the attribute manager, change the light width and height to around 100 centimeters. Before going through with the light parameters, if I go to the light tab, here you can change the light type to any of the other light types that we mentioned earlier after you have created a light, which can be very, very useful. Now we can get back to the main tab. Here you can find most of the light attributes. First off, you have color. You can control the color of your light using this parameter. Let's play around with some colors here. Also, if you click on this menu here besides the color parameter, you can change the value or the color type from constant, which allows you to pick a color for your light, to texture or shader network. And using those 2 other options, you can define a texture to be used as the color of your light. We discussed that later on in the lesson. Then we have intensity that controls the brightness and intensity of the light. So as I increase it, we get more light emitted into our scene, and if you wanted less, simply decrease this value. Then we have this exposure value, which does exactly what intensity parameter does, but in a different measurement. Exposure is based on stops. So when the exposure is increased from 0 to 1, you are doubling the amount of light being emitted from the light source. From 1 to 2, you are doubling the overall amount of emitted light again. Now, I personally tend to mix between intensity and exposure. If I want a subtle change, I use intensity, and if I wanted more drastic adjustment, I tend to use the exposure value. In this case, let's set the intensity to 1 and exposure to 5. Then down here, you can change the size of your light. I can simply alter the width and the height of my light. Let's reduce the light size to maybe 10 by 10 centimeter. When you decrease the size of your light, you're making the shadows sharper. And as you increase your light size, you're making the shadows to be more diffuse, as you can see in the IPR. That's one of the first things you need to learn about lighting. The smaller the light source, the sharper the shadows get, and the bigger the light source, the more diffuse the shadows will get. Let's keep the light size at around 100 centimeters. Now let's skip some of these parameters for the moment and talk about this normalize parameter that relates into the size of your light. When normalize is turned on, and it is by default, increasing the light size won't affect the intensity of the light. It just makes the shadows to look more diffuse. Let's select our scale tool and make our light smaller and bigger. And as you can see, because normalize is turned on, we only change how sharp or diffuse the shadow is when we make the light bigger or smaller. If I uncheck normalize and start decreasing and increasing the size of the light, you can see making the light bigger equals to having a brighter scene and emitting more light, and at the same time the shadows getting diffuser. And if I decrease the size, we get less emitted light and sharper shadows. People tend to work differently, but I tend to keep the normalize parameter on, so the size of my light only affects how the shadows look. For now, let's turn on normalize and set the size back to 100 centimeter. Then there is this look at parameter, which allows us to define an object and the light will be pointed towards that object, which can be very useful, obviously. You can do the same using Cinema 4D's target tag. In this case, we can define the chair as our look at object. And now if we move the light around, it will be oriented towards the chair at all times. We talk about resolution later on in this video. Next, we have samples. To understand this better, let me unhide this sphere in the scene, which has a rough chrome material applied to. And let's move the light around to get a better reflection. Using samples, you can control the overall quality of your light, which is the noise in the soft shadows and the noise in direct specular highlights. If you take a look at the IPR, you can see we have quite a lot of noise in the direct specular reflections, in the shadow edges. So let's create a snapshot and increase our light samples to about 4. As you can see, the noise is basically gone in the shadow edges. Let's make a snapshot and compare it to the previous render. Now if you take a look at the shadow edges and at the direct specular highlights, you can see it is cleared up significantly. Now you might ask, what is a great value to put in the samples to always get noise-free direct lighting? It really depends on the scene, but 4 is normally a good value because it will be obviously multiplied by the camera samples as well. So probably 4, 5, you really don't need to get any higher than that. But if you saw any noise in your direct lighting, in your shadow edges, you can obviously go higher. But personally, I think 4 or 5 are great values to put in here and normally work. Let's continue on with the rest of the parameters. First, let's change the size of the light to 250 centimeters and clear the look at object and make sure the light is fairly straight. I'm going to open up the sphere material and set the roughness to 0 so we get sharp reflections from our sphere. Now we can clearly see the light source in the sphere, the reflection of the light source, obviously. Now the next parameter is roundness, which changes the shape of the light from a square at 0 to rounded corners at 0.5 to a disc at 1. Okay, so you can get a disc light from a quad light if you set the roundness parameter to 1. Soft edges specifies a smooth fall off for the edges of the light. The value here specifies the width of the soft edge from no soft edge at 0 to smooth fall off all the way to the light center at 1. At 0, you can see we have this clear-cut light source, and as we increase the value, we get a light source with softer and softer edges. I'm going to leave this parameter at 1 for now. And hide the sphere and hide the chair again and change the IPR camera to the active camera, and let's move around in the viewport to find a nice angle. Now, I just want to make sure the light source is also in the view. Now, next we have spread, which is a very useful way of shaping your light. Spread basically allows you to have more or less focused light. At 1, we get a diffuse emission with 180 degrees spread. And as I decrease the spread value towards 0, we get a more directional light. This is one of my favorite parameters, and I use it constantly because it gives you the ability to shape your light and direct your lighting very, very specifically as you want. Now, at this point, you might wonder, where is the light source itself? Right now, the camera can't see the light source, and to see that, we need to increase this camera visibility value from 0 to 1. Now we can see the light itself, and we can play around with the spread value a bit. But let's set it back to 1 for now. And change the IPR camera to our main camera and set the light size to around 50 centimeters, which results in this kind of sharp shadows. Next, we have cast shadows. If enabled, we are going to get shadows from the light, and if disabled, the light won't cast any shadow. Next, shadow intensity is quite self-explanatory. And here, using shadow color, you can change the color of the shadows. Let's get back to black, which is the color of the shadow. Now, next we have cast volumetric shadows. In the render settings and under environment, add an atmosphere volume shader and increase its density to around 0.4. And now we have some nice atmospheric volume. Let's also change the light size to around 150 centimeters. And decrease the spread to around 0.08 and exposure to about 3. Also change the camera in the IPR to the active camera again and get a bit closer to the chair. Now IPR renders the active view in the viewport. So cast volumetric shadows control if we are going to have volumetric shadows or not. It's a bit hard to see in this scene, but if we zero out the diffuse contribution of the light, so the light wouldn't affect the diffuse portion of our shaders, you can clearly see the atmospheric shadows and the ability to turn them on and off using the cast volumetric shadows. It's subtle, but it's there. Let's set the diffuse contribution of the light back to 1. Then there is this volume samples, which relates to Arnold volumes, basically fire and smoke, and not the atmospheric effect that we have right now. I explain this option later on when we discuss Arnold volume. If I wanted to increase the quality of my atmosphere volume, I needed to open up my atmosphere volume shader and increase the samples there. We discuss atmosphere volume and fog in the section of the course later on, one of the later lessons in this section. For now, let's get back to the render settings and clear the atmosphere and get back to the main camera and set the light exposure back to 5 and spread to 1. Then there are these parameters down here that control the light visibility and its effectiveness on different shading components. We talked about this camera parameter that controls the light source visibility. We have diffuse, which controls how much this light is going to affect the diffuse portion of our shader. If I zero it out, you can see the light is no longer affecting any diffuse portion of our shader, but you can see the light is still affecting the specular portion, substrate scattering, and so on. If I increase my diffuse and to 1 and zero out the specular, the light no longer affects any specular portion of our shader and it's not visible in the direct specular reflections. Next, we have this transmission contribution. Let me unhide this glass object in this scene and make sure the glass is between the camera and the light source. Transmission contribution controls whether the light source is visible through transmissive objects or not. This should be at 1 by default, which I think it's not. Let's get back to the main camera and hide the glass. Using SSS, you can define how much the light is going to affect the subsurface scattering effect. And using indirect, you can define how much the light can contribute to the indirect GI diffuse. And if I set the diffuse ray depth in my render setting to about 3, so we can get a bit more pronounced indirect lighting, even though the scene in a way has a very strong direct lighting, which doesn't really allow for much GI, but this should be good enough. Now, if you zero out the indirect contribution of the light, you can see how the light won't affect the indirect lighting when this value is set to 0. So because we have only this light and its indirect effect or indirect effectiveness is set to 0, we don't get any GI. But obviously if we had other lights, they would still contribute to the GI and indirect lighting. Let's set it back to 1. And finally, we have volume. Let me temporarily add an atmosphere volume again to my environment and increase its density to about 0.25. And change the IPR camera to the active camera and zoom out a bit. Using volume, you can define how much your light affects atmospheric effects. At 0, it won't, and at 1, it is fully affecting the atmosphere. Let's delete the atmosphere volume again and get back to the camera. To get a physically accurate render, leave these values at 1. Now we have max bounces, which if I quote Arnold help, is the maximum number of times the energy from this light will be allowed to bounce in the scene. So a max bounce value of 0 means that the light will only be part of the direct lighting computations, effectively disabling GI for the light. Note that this value works along with the global ray depth controls. So if you remember, the total ray depth limit is around 10 by default. So the default value of 999 bounces per light is just a theoretical maximum. In practice, the global ray depth limits are set much lower. Next, we have this AOV light group, which we will discuss it later on in the rendering section of the course when we discuss AOVs. Then there is detail tab. If we enable use color temperature, you can define the color of your light based off of Kelvin temperature degrees. Higher values are going to make the light bluer and cooler, and lower values make it more orange and warmer. This blend checkbox here allows you to blend the Kelvin color with the color defined in the main tab. It gives a 50% mix between the two. Also, you have these light filters, which is a great set of tools to modify and shape lights. We have a specific lesson about light filters, so let's skip it for the moment. Then you have the default Cinema 4D's project tab, which lets you exclude and include objects from the light. Let me just disable this blend and use color temperature and use a simple white color. As I said earlier, you can actually control the color of your light with a texture by assigning a texture to the color attribute of your light. A very useful scenario would be for a studio kind of product photography setup when you have a very reflective subject and the light reflection can't be just a simple white plane that we have by default from the Arnold light. And you want to see a real world softbox or umbrella being reflected off your subject. You can assign a softbox texture to your light color and get more realistic lighting and reflections. I'm gonna quickly unhide my sphere and hide the other objects and set the light size to around 350 centimeters. I'm gonna zero out the soft edge so we get a simple plain area light, and let's get quite close to the sphere so we can see the reflections of the light. Now select the light again and use this menu here to change the color type to texture. And if you go to the text folder of the project files for this section of the course, you can find this texture called Umbrella, which is an EXR file from a reflective umbrella that is used in photography studios. Let's open it. And now we see this beautiful reflection in our sphere. And if I zoom out a tad to see the light source itself, we get this beautiful lighting from that assigned texture. One last thing, you can change the color type to shader network and load your textures that way. In this case, if we want to load the same umbrella texture, you would change the color type to shader network. Then we can create an image shader from the Arnold menu in the material manager. Open up the image shader. And load the same umbrella texture from the project files folder. And now you can drag and drop this image shader to the color field of your Arnold light. Now, the advantage of adding your textures using a shader network is that now you can open up the shader network for this texture and do all sorts of adjustments like color correction on your texture. For example, let me press Ctrl Tab and add a color correction node after my image node, and connect the color correct node to the beauty output of the network. And now you can color correct the texture that controls your light color as you wish. And finally, you have the resolution. Without going into any detail, try to set the resolution here close to your texture resolution. For example, the texture I'm using is about 1500 pixels, so I type in 1500s to get a tad faster render and less incoming noise from that light source. It really doesn't affect the light that much, but it's a good practice to set the resolution close to your actual texture resolution. So that's about the common parameters of the Arnold light and specifically quad light. The lesson is done and you can skip the rest of the video and move on to the next one. But in good conscience, honestly, I can't leave this scene like this without making a beautiful image out of it. Let's get back to the camera. I have the second camera in my scene, which is a bit farther away from the subject. Let's change the IPR camera to that. I think the resolution is a bit off, so let's go to the render setting and change the resolution to 1000 by 1500. I'm going to turn off the light that we created at the start of the lesson. I already created another simple quad light and positioned it to the left of the chair. Here it is. Its size is around 150 centimeters with the exposure set to 5.5 and spread at around 0.5, which gives us this nice soft light from the left side. Now, to make this more realistic, I'm going to use an HDRI image as my environment light using an Arnold sky. So let's add an Arnold sky. I know we still haven't talked about Arnold sky, but just bear with me. We will talk about all of this later on. Now I'm going to change its color type to shader network. Now create an image shader. Rename it to something like HDRI so we can recognize it. And load this HDRI image called bathroom and change the color space to a utility linear sRGB for this HDRI as we are in ACES, and assign it to the Arnold sky. And finally, let's rotate the Arnold sky to around 307 degrees and change its sample to around 4. And this gives us a nice fill light to our key light from the left. And now we can wait for the IPR to work on the render a bit more. And this is a better render compared to what we had before. As an exercise, you can see the render is a bit noisy. Try making it clean, noise-free, by using the knowledge you acquired from the previous lesson. I'm gonna go ahead and do that and take a final render and save it to the render folder that you can access with your download, and save that scene out as a separate Cinema 4D file for you. In this lesson, we discussed area light in its quad shape, and in the next lesson, we briefly talk about a few other area lights that we have. See you there.